So we have entropy, and we give it the symbol capital S. And what is the entropy? It's a little hard to envision in our mind because we can't see it, but entropy can be thought of as a measure of the randomness or disorder in a system. So as disorder increases, the entropy increases. And as disorder decreases, entropy decreases. So if you consider your room, and your room's real clean and neat, then the entropy is small. And if you go mess it up during the week, and then it's a mess at the end of the week, then you have increased the entropy, increased the disorder, and the entropy of your room has increased. So you can have a spontaneous process where things just become random or disordered, but you would have to provide a lot of work to tidy things up, fold all your clothes, put them away. So we can cause entropy to decrease. But in that process of your cleaning the room, the entropy of the universe has increased. So you might say, why? Say you have your room and that's the system, and your room's a mess. And you go in and you fold all your clothes and put them away and clean it and everything. And so now you've decreased the entropy of your room. You've ordered it. But how does that increase the entropy of the universe? Well, to do all that work, folding your clothes, cleaning and everything, you've expended a lot of energy. So you've heated up your environment, body heat, all that muscle contraction and everything by you working has produced heat, and your body has given heat up to the environment. And so that heat has left your room, gone into the universe, and you've increased the entropy of the universe by heating it more than you decreased the entropy of your room, the system. So the entropy of the universe increased by you cleaning your room. So this was the definition in the 1850s when scientists were working on the steam engine. Boltzmann, about 50 years later, came up with another definition of entropy on the atomic molecular scale. And he said entropy is equal to K, Boltzmann's constant, times the natural log of W, the number of ways that you can arrange a system with a particular energy value. So K is Boltzmann's constant. So it's just a number, and it happens to be the ideal gas constant divided by Avogadro's number. And W is a number of ways to arrange a system with a particular energy. So if there's only one way to arrange a system with a particular energy, then W is 1, the natural log of 1 is 0, so the entropy would be 0. If there's more than one way to arrange a system, then W will be 2 or greater, and then the entropy will be non-zero. So let's look at an example where we can help us to understand this. So say we have a couple of pair of dice. So we have a pair of die, and we want to look at the value of the die and the number of ways of achieving that value. So say we look at the lowest value, 2. This would be snake eyes. There's only one way to roll snake eyes. each die has to be 1. So there's just one way of getting the value 2. So now we want to see how many ways can we get the value 3. Well, there are 2 ways. We can have a 1 and a 2, or we can have a 2 and a 1. So there are 2 ways that we can roll the value 3. So let's consider the value 4. How many ways are there of getting a 4? Well, we can have doubles, 2 and 2, or we could have 3 and 1, or 1 and 3. So there are 3 ways of getting the value 4. So we'll do one more example. The value 5. How many ways are there of getting 5? Well, we can have 3 and 2. We can have 2 and 3. Or we can have 1 and 4. Or we can have 4 and 1. So there are 1, 2, 3, 4 ways of getting the value 5. So if these values instead of are energy values, then the number of ways will tell us the entropy of the system. So if there's only one way of getting a particular energy value, say the value 2 joules or whatever the energy unit is, then the entropy is 0. But if there are more than one way, then the entropy will be positive. So now you can see that from Boltzmann's equation, we can calculate an absolute entropy, just a number for the entropy. When we looked at the enthalpy, H, we could only see changes in H. So we'd see heat flow for a process. But with entropy, we can get an actual value for the entropy.